figure shows an alternative apparatus to find the speed of sound in air using a resonance tube with one end closed. The principle of this apparatus is similar to principle of the apparatus normally used in school laboratory. The resonance tube in this apparatus is a glass tube with a calibrated scale. The water level in the resonance tube is raised and lowered by raising and lowering of water level. Reservoir X, which is connected to a resonance tube with a flexible rubber tube. Part A. What type of wave is formed inside the tube at resonance? We know that inside the tube there is a sound wave. It is a longitude and stationary wave. Part B. You are given a tuning fork of non-frequency F and asked to obtain the resonance length L0 and L1 corresponding to fundamental note and first overtone respectively. Part 1. Draw the wave pattern of the two modes of vibration and mark the length L0 and L1 in correction E nodes, antinodes. You are expected to draw the tube for the first overtone. Fundamental and first overtone. We have to draw fundamental and first overtone. For the fundamental frequency, we can observe a wave pattern like this. This one is the node, this space is antinode, and this is the incorrection length L0. For the first overtone, we can get a wave pattern like this. Again, this one is the incorrection. They have given length for the first overtone A1. This point is a node, this point antinode. Again, this point node, this point antinode. And we have to remember that approximately length of this resonance situation should be 3 times of this one. Then part 2, 1. If lambda is wavelength corresponding to the fundamental node, write down expression for the lambda in terms of L0 and E. This one is B1. Now we have to write the answer for B2. We can get lambda of 4. There is a half of loop. Half of loop means 1/4 of wavelength equals to this total length L0 plus E. Then we can get lambda 4 times L0 plus E. Then second part, write down similar expression for the wavelength corresponding to the first overtone. For the first overtone, lambda of 4 times 3. There are three parts like this. Lambda of 4 into 3 should be equals to L1 plus E. Then we can subject lambda 4 3 times L1 plus E. Then third one, if V is the speed of sound in air, derive an expression for V in terms of known and measured quantities. We can get the difference between L1 and L2. Difference between L1 and L2 should be half of wavelength. Then we can write lambda over 2 equals L naught and L1. L1 minus L naught. Then lambda equals 2 times L1 minus L0. Now we can use V equals S lambda. Velocity of sound V F times lambda is this one, 2 L1 plus L1 minus L0. In part C, before taking measurements for L0, the water level in resonance tube has to be raised up to the top. Explain the reason. We have to get fundamental frequency. When getting fundamental frequency, we know that resonance length is a minimum value when comparing with other overtones. Therefore, we have to increase the resonance length from 0. Then we can write to obtain fundamental without missing it. Or we can write it to confirm that we have obtained the fundamental frequency. Then part D, write down two major differences in the experimental procedure when using the apparatus given in the question compared to the method adapted when using apparatus gently available in school laboratories. The apparatus in school laboratory is not fixed. In school laboratory, we are not using a fixed tube. Therefore, we can write first difference is tube is fixed. Then second one, normally in the school laboratory, we are using meter ruler to obtain readings. But in this one, there is a calibrated glass tube. Then we can write glass tube has been calibrated. Then part E, at room temperature 28 degrees, when the 512 Hz tuning fork is used, the corresponding length of the resonance for fundamental note and first overtone are to be found 15.5 and 50.5 centimeters respectively. Calculate the speed of sound in air in room temperature. We have to use this equation. We can write V equals 2f times L1 minus L0. Two frequencies 512, it is given in the question. Difference between two lengths 50.5 minus 15.5. But these values are in centimeters, we have to convert it to meters, multiply by 10 to the power minus 2. 2 into 512, 1024. Multiplied by, I will consider the difference, 10 minus 5, 5, 4 minus 1, 3, 35 into 10 to the power minus 2. You can multiply these values and obtain 358.4 meters per second.